Hi everyone. In this video, we are going to talk about histograms. We are going to be looking at an example from the Cambridge textbook, AS level textbook. And this example is from exercise 1B, question 8. So here we are presented with a histogram and we have to answer some questions on that histogram. It's very important that we understand that the histogram present a type of bar graph where the class widths are different or depending on how the classes were grouped or how the classes were organized from the data that you were provided with. And we are going to have class width against frequency density, and that is what we call our histogram. So please do take note or remember that, or if you don't know, get to know that the frequency density that you see indicated on the y-axis, frequency density, I'm going to abbreviate FD, is equal to the frequency divided by the class width. So if we want to play around with this formula, we can play around with it. So if in this case, I already know that I have the frequency density and I have the class width, which is also represented on the axis that is labeled length. I can also say if I wanted the frequency, because I can see there's no frequency here, so I wouldn't know from this 0 to 10, what is the frequency here. So I can also just say, play around with this formula, make F the subject of a formula. I'll have that frequency will be frequency density times class width. One thing to also get to know is when I'm looking for frequency in a histogram, I can also say that that will be the area of this bar. So it will be also the same as length times breadth for that bar. The area will also be equivalent, the area of that rectangle will also be equivalent to the frequency from that class. Okay, so let's get to our question. So we are told the length of the 575 items in a candle maker's workshop are represented in the histogram. First question, what proportion of the items are less than 25 centimeters long? Very important, read your instruction, understand if you need to underline, highlight what is important to you so that you can be able to respond to the question and not just reading to respond, but reading to understand and also relate your question to the histogram that you're presented with. So they said, what proportion of the items, so emphasis on proportion. So we are not looking for how many items are less than 25 centimeters long. We're looking for the proportion of the items that are less than 25 centimeters long, meaning we want to know how many items are less than 25 centimeters long, and we make it out of the total number of items that we are given here, right? So we then have to come to our histogram. Then we go and try to position or locate where 25 centimeters is on the axis that is representing length. So we see that it's there. So meaning we want to know how many items are from this to that. Remember earlier I mentioned that these bars are also representing the frequency. And in this case, the frequency is actually the number of items for this class. Meaning from 0 to 10 centimeters, I have 10 by 5. So it means I can also just say 5 times 10, which gives me 50. So it means I have 50 items from 0 to 10. And with this part, this rectangle, the next class, which is 10 to 25, I can see that from 10 to 25, I have 15. So if I basically say 15, which is coming from my class width, times the 25 that I have on my frequency density, I'll then have my area of this bar, which also represents the frequency for that class, which means also then giving me the number of items that I have from 10 to 25 centimeters long. And this gives you 375. So basically, in this class, I have 375 items, and from 0 to 10 I have 50 items. I could continue. This would be 5 by 10. So I have 5 by 10 giving me 50. So I also have 50 items here, and if I want I can also continue. So now that I know that I can get my number of items by finding the area of the classes, or I can use the formula frequency density by class width, which is equivalent to what I just said, the area of each of these bars. I can now come and respond to my question. So I can come and say, okay, so for the items that are actually less than 25 centimeters long, which is now our answer to A, I'll have to start from 0 until 25. So I can see that I could not find these items together. I needed to split them up from 0 to 10 and then from 10 to 25 because they were presented in different classes and they had different frequency densities. So it means for the first one, I'll then say, oh, so I actually have 50 there plus 375. But since they asked for the proportion, what proportion of the items are less than 25 centimeters long, I needed to make that out of the total number of items, which is 575. So simplifying that, actually adding up first gives me 425, and out of 575, and that simplifies to 17 over 23. Okay, so that is our answer to A. For B, I'm going to use a different color. I unfortunately have to use the same graph. I just hope you're going to be able to stay focused with the colors that I'm going to use. But I also try to just draw out what I need for question B here. Just add some rectangles here to just present what I'm looking for. So here in question B, they said, estimate the number of items that are between 12.4 and 36 centimeters long. So it means for that, I'm supposed to come and try and see where is 12.4. It's definitely after 10. So it means I'm starting from 12.4 and I'm going all the way until the last part, which is 36.8. That's what I want to know. I want to know how many items are represented. So 36.8 would be somewhere here, somewhere there, and 12.6 would be somewhere there. So I didn't want to just use that graph there. So I'm going to clean that up because I'm going to still use the same histogram for question C. I hope you are able to relate it back to the original histogram. I just used this to explain to you. Please, my apologies for this ugly 2, but it's supposed to be not 2 but 4. So I don't know. It's supposed to be like that. So I hope that looks better. So I'm looking for what are the number of items I have from 12.4 until all the way to 36.8. I can see that the class width are not the same. First of all, I also don't have the same frequency density. So the length and the breadth are not the same for these rectangles. So I want to know, so from here, from 12.4, I have to go until 25. So I have 25 here, and here I have 30. So I have to find the area of this first rectangle, which is then going to be 25 minus 12.4, which will give you 12.6. And of course the frequency density, as you see here, 12 is still just 25, so I have 25 there. So basically for this first bar here, that number of items, or those number of items, will then be, I'll find them by saying 25 times 12.6, and that gives me for that first class from 12.4 until 25. And then from 25, I then have to use my area. So I can see that this is a 5 by, and if I look at this, height is 10. So it's a 5 by 10. So here I have 10. So I will then say, so plus a 5 by 10. That's the next bar. And the last one, I can see from 30 to 36.8, I'll have a 6.8. And I can see that the height for that, or the frequency density for that, is 5. So I'm going to say plus 5 times 6.8. Sorry, yeah, 5 times 6.8. So we have these 3 to represent what we want, from 12.6, which approximately is there, until all the way to 12. Let me use a different color so that you can just look at or focus a bit. So I'm starting there and I'm ending somewhere there at 36. So I want to know how many items are represented from this part of this histogram. 25 times 12.6, that gives me 315 plus 50, of course, plus 5 times 6.8 should be 34. So I have 34. So adding 34 plus the 50 plus the 315, and that gives me 399 items. So basically the number of items that are between 12.4 and 36.8 centimeters long are going to be, so from this part until this part, they are going to be 399. Okay. So with question C, they're saying, I'm going to try, I don't know if cleaning up will help. I do hope you took note of that. But maybe I do need some, so I'm going to just keep that part, or at least keep in mind that this is 375, but I also know how to find it, so it's also fine. So what I'm going to do then for the next part is understand, first of all, understand what you are presented with. The shortest 20% of the workshop's items are to be recycled. Calculate an estimate of the length of the shortest item that will not be recycled. So basically 20% items that will be recycled. So what you're going to do is, first thing we want to understand, what is 20% of the items, which is of 575. And that gives you 115, right? 115 items. So I have 50 already here. We calculated that 10 by 5. We also have 375 here. So it means until here I have 50. So from this 375, I have somewhere, I'm going to use a red, somewhere until somewhere from here, I need 65 items to add them to the 50 items, so that I want to know what is this distance. This distance, what is it? 115 items are the shortest items that will be recycled, right? So the 115th item will be the highest, like the last, the upper bound of the items that will be recycled. So I need to find, I can already see 50 items already from 0 to 10. So I need to get 65 from the next class, right? So it means I have to get 65 items from these 375 items, so that they can add to the 50 to give me what is these centimeters that will now be the upper bound of the class that will be recycled, and the lower bound of the next class that will not be. The lower bound, which means the shortest item, that will not be recycled, because it's going to be the lower bound of the next part of number of items that will not be recycled. We were asked to find the estimate of the length of the shortest item that will not be recycled, right? So basically, we first want to find what is the percentage, what is this percentage of the 575, which we found was 115, which is telling us that these 115 items are the ones that are going to be the shortest, and they are the ones that are going to be recycled. Okay, so now we need to find until where are they, until how many centimeters. So we'll have an upper bound there at the end, at the 115th item. So that upper bound will now be our lower bound, which is going to be our shortest item, which is going to represent the length of our shortest item. So that is what we're going to do. So what we will then do is, we just want to know, we already see we have 10 centimeters there. So basically part of our answer we already have. So since we said, okay, so from this we take out the 50, because we can already see we have, we already have the 50. So we have 10 centimeters so far of the items that will be recycled. We want to know what is the next part. What is the 65? What is the last, the upper bound of this class that will be recycled to make up that 115? So one way to do it, this is the 65 I'm talking about. Let's say this is the 65 I'm talking about here, 65 items. So I already know this is 25. So basically we said that frequency is frequency density times class width, right? So it means we can say 65 is equal to 25 times the length that we don't know, right? So meaning we then have to divide both sides by 25, and the length will give us 2.6 centimeters. So it means that is 2.6. So it means I have a 2.6 here, so which is what I'm going to add to the 10 that I already have, 2.6 centimeters, and that gives me 12.6 centimeters. And that gives me my answer. So I found what this is, which gave me the 12.6, right? And that 12.6 found the upper bound of the class that will give me the shortest, the 20% shortest items that are to be recycled, so that that upper bound becomes the lower bound of the next class, which represent then the length of the shortest item. And I'm done. You could also say if 375 is equal to 15, what is 65 equal to? Then you cross multiply and solve for x. So you could do that as well. Thank you so much for watching.